Have you ever wondered what kind of stories a tree would tell if it could talk? Well, in a way, it actually can. You see, every single tree trunk holds a secret diary, a detailed record of its entire life, written in a special language of layers and rings. So let's dive in and figure out how to read. So, what exactly can a tree trunk tell us? Turns out, a whole lot. It can tell us its age, sure, but also the story of good years and bad years, and it can even reveal the secrets to its incredible strength. It's pretty much an entire autobiography, just waiting for us to discover it. Okay, so this diagram right here is going to be our map for this journey. We're going to peel back each of these layers you see one by one. We'll start from the very outside and work our way right into the heart of the tree. Ready? Let's go. All right, our first stop is the dynamic, living part of the tree. These are the layers just beneath the surface, the ones that are constantly working, nonstop, to keep the tree alive and growing. So imagine we're looking at a slice of these outer layers. On the very outside, you've got the bark. That's the tree's armor. Simple enough. But right underneath that is where things get really interesting. First up is the phloem, a soft layer that acts like the tree's plumbing system, sending food down from the leaves. And then there's the cambium. Now, this layer is paper thin, but it's the absolute engine room. It's the factory that creates new wood on the inside and new bark on the outside. This is where all the growth happens. Let's move one layer deeper. This is the sapwood. Think of it as the tree's massive circulatory system. It's made of living cells, and get this, it's about 75% water. Its whole job is to constantly pull water and nutrients all the way up from the roots to the highest leaves. This is the active, living, working part of the wood. Now, we're going to journey even deeper. We're leaving the living, breathing parts behind and entering the tree's structural core. This is the part that gives it that immense strength, the part that lets it stand tall for decades or even centuries. Welcome to the heartwood. This is the tree's skeleton. It's made up of old, inactive cells that have hardened over time. It doesn't transport water anymore. Its one and only job is to provide incredible structural support. It is, quite literally, the backbone of the tree. And this chart just lays out the difference perfectly. Look at this comparison. The sapwood is wet, alive, and it's all about moving stuff around. The heartwood is dry, dead, and built for pure support. This difference is exactly why the heartwood is usually darker, denser, and way more resistant to rot, which is why it's so prized for things like construction. Right at the very dead center of it all, we find the pith, this tiny little core. This is where it all began. It's the original fragile shoot from the tree's very first year of life. This entire magnificent structure grew out from that one tiny spot. Okay, so we've seen the layers, but now for the part that really feels like we're reading a diary. The growth rings. Each one of these is like a chapter in the tree's life story. And the code is actually pretty simple to crack. Each full ring you see here represents 1 year of the tree's life. The lighter, whiter band, that's from all the fast growth during a wet spring. The darker, denser band is from the slower growth during a drier summer. So a really wide ring means it was a good year with plenty of water, while a narrow one tells us it was a tough year, maybe a drought. And here's something cool that connects this biology to the wood you see every day. When you look at a tree stump, you see those concentric circles, right? But when you cut that same tree into lumber, you're slicing those rings lengthwise. And that's what creates the beautiful parallel lines we call the grain. It's the exact same feature, just seen from a different angle. So we've seen the big picture. Now let's zoom in. I mean, way in. We're going down to the microscopic level to find out what gives wood its legendary properties. This right here is the hidden architecture of wood. You see, it's not just a solid block. It's a complex, highly organized structure of cells and tubes that looks more like a honeycomb or a tight bundle of straws. This structure is the key to everything. So how does nature build something so strong at a microscopic level? Well, there's a perfect analogy for it. Think of reinforced concrete. In wood, the two key ingredients that play these roles are cellulose and lignin. So the crucial thing is how these two work together. Cellulose forms these long, incredibly strong fibers that provide tensile strength and flexibility. That's the rebar. Then lignin acts as a rigid glue that binds all those fibers together, providing compressive strength and stiffness. That's the concrete. Together, they create this amazing natural composite material that is both strong and lightweight. This unique microscopic structure, with all these fibers pointing in one direction, leads to one of wood's most defining and useful characteristics. And that characteristic is called anisotropy. It's a fancy word, but it's a simple idea. Wood behaves differently depending on which direction you push or pull on it. Because all those cellulose fibers are lined up, wood is incredibly strong along the grain, but much weaker against it. And the difference is absolutely staggering. Wood can be up to 20 times stronger when force is applied along the grain compared to when it's applied across the grain. This is the fundamental principle that every woodworker and engineer has to understand to use wood effectively. So, after our journey from the bark all the way to the pith, from the yearly rings down to the microscopic fibers, I'll just leave you with this one final question. The next time you run your hand over a wooden table or lean against a tree, will you see just a material, or will you see the strength, the struggle, and the incredible history of a living thing?